You're sitting in the exam hall. The clock is literally ticking down. You turn the page and see what looks like a classic, straightforward calculation question. You've studied for weeks, you know your formulas inside out, and you are ready to secure those final, absolutely crucial marks that are going to dictate your grade boundary. We're looking at the foundational concepts of energy, work, and power. Let's look at exactly what you're up against right now. Consider this scenario. The paper says, calculate the kinetic energy of a 2 kg car moving at 3 meters per second. You immediately recall the formula, right? Kinetic energy equals 1/2 mass times velocity squared. Brilliant. You plug in the numbers, 1/2 times 2 times 3 squared. The math is completely flawless. The 2 cancels out, 3 squared is 9. You write down 9 on the answer line and move on, feeling incredibly confident. But here's the critical question for you. Do you actually think that answer secures the mark on a Cambridge physics paper?
The reality is, that perfectly calculated answer earns exactly 0 marks. Nothing. It's a complete 0. And honestly, it is a devastating result because you actually knew the physics, you knew the formula, and you executed the mathematics perfectly. Yet, the examiner just gave you absolutely no credit. So, what happened?
Well, the ruthless reality of the examiner's mark scheme is this. You wrote 9. But 9 what? 9 apples? 9 meters? The answer is 9 joules. Missing units is just one of the incredibly painful learner mistakes that instantly evaporates your marks. Examiners are trained to deduct points without hesitation if you forget that capital J. But it doesn't stop there. Take rounding your numbers way too early in a multi-step calculation, or providing vague explanations that lack scientific terminology, plugging the wrong variables into your equations, or writing conclusions that just aren't explicitly backed up by the data provided. These mistakes are exactly what put your grade boundaries at severe risk.
Okay, let's dive into this, because this brings us to a fundamental truth about your exam preparation. If you are making these kinds of mistakes, it means your standard studying techniques are completely failing you. Simply memorizing formulas is just not going to save you when you're up against a Cambridge examiner.
Look, when you flip through the exact syllabus for the Cambridge IGCSE physics course, you'll see Chapter 6 covering energy stores, transfers, and conservation of energy. You see Chapter 8 covering work and power, including exactly how to calculate work done. Now, a normal student will just flip to the page, read about energy stores, or read about doing work, and think, okay, I'm prepared. But just staring at the textbook isn't enough to pass the examiner's mark scheme. The textbook teaches you the physics, the mark scheme tests your ability to communicate that physics under very strict rules.
In a moment, I'll show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue obvious.
This brings us to the high mark framework. This is your final minute upgrade. If you want to stop bleeding marks on simple, silly errors and start writing answers that examiners are literally forced to give full credit to, you need a rock-solid system. So I'm going to provide you with the ultimate system to transform a chaotic last-minute revision plan into an impenetrable, top-scoring strategy. Here is how our foolproof 4-step framework breaks down. Step 1. Concept. You absolutely must explicitly state the underlying physics principle. Are we dealing with the conservation of energy? Are we talking about power as the rate of doing work? Put it on paper. Step 2. Evidence or data. This is where you pull the exact numbers from the question, plug them into the correct equation, and, crucially, as we just learned, include the required units. Step 3. Scientific reasoning. You can't just drop an answer and run, you must explain the why. How does the data connect back to the concept? And Step 4. Examiner wording. This is your secret weapon. You must use the exact, specific vocabulary the examiner is scanning for on their rubric.
All right, time to spot the examiner's trap. Let's put this into practice right now. I'm going to challenge you to apply this new framework to a classic, high-stakes exam question combining energy, work, and power. Let's see if you can spot exactly where students fall apart.
Here is your challenge. Explain how motor efficiency is calculated and why it is never 100%. I want you to mentally pause for a second right now. Seriously, think about exactly what you would write down on that dotted line to answer this. Predict your answer in your head. How do you calculate it, and why isn't it perfect? And this brilliantly illustrates the difference between an ordinary student and the top band student. A standard answer might simply say, useful energy out divided by total energy in. Some energy is lost. To the average person, this sounds perfectly fine, right? It seems logical. But to an examiner, it is severely flawed. Compare that to the second answer.
Useful power output divided by total power input multiplied by 100%, energy is transferred to the thermal store due to friction. That second answer is an absolute masterpiece of exam technique.
Let's act as the examiner with our red pen and break down exactly why that second answer gets maximum marks using our framework. First up, evidence. They use the exact equation, formatting it properly, and, vitally, multiplying by 100% to get a percentage. Second, concept. They specifically named the thermal store. Third, reasoning. They identified friction as the precise mechanism causing the inefficiency. And finally, examiner wording. They completely avoided the word lost. This is a massive trap. In physics, due to the conservation of energy, energy is never truly lost or destroyed. It is simply dissipated or transferred to a less useful store, like the thermal store. Using the word lost is a massive red flag that will instantly cost you points. This framework ensures you fulfill the command words perfectly every single time.
So, the crucial point is this. You now understand how to structure your theory answers. You know how to identify the concept, pull in your evidence, apply reasoning, and dodge those dangerous trap words like lost. You have the theoretical framework locked down. But listen closely, because your final minute upgrade is not finished yet.
You have the framework for theory, but without the full revision map for complex calculations. I'm talking about those multi-step problems where you have to combine kinetic energy with gravitational potential energy or calculate work done before finding power. Your grade is still incredibly exposed. Knowing the theory won't save you if you stumble on a massive 4-mark calculation question because you don't know the exact sequence the examiner demands. Watching the past paper walkthrough for these calculation skills is an absolute requirement for your success. It's not optional.
To get that full revision map and secure every single mark, here is exactly what you must do right now. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGSC to excel in your Cambridge examinations. Because remember, in physics, energy is never truly lost, but without the right strategy, your marks certainly will be. Will you be ready when the timer starts?